Hello, I'm Jay from Sirocco and I want to show you a sneak peek of our Haskell course on everyday optics. This course is for people who want to understand when and how to use optics, but also when not to use them. Optics should be used, but optics should be used with awareness. In the course we talk about the most common approaches, various techniques, popular libraries, and naming conventions. But before we dive into these topics, we have to establish some common terminology and building blocks. In this section, we are going to give an overview of optics. What is the difference between optics and lenses? What is the difference between lenses and lens? Optics and optics? And what is the major optics and what can they do? Note that this is not a comprehensive overview or learning material or introduction for optics. It's just a simplified overview so we can speak the same language later in the course. It's important to clarify terminology before we starting to dig too deep. Optics embody a variety of techniques for data manipulation, which includes lenses, prisms, and traversals. They allow us to read and modify parts of different data structures, such as fields of records, variants of unions, and elements of containers. Lenses is a specific type of optics that allows manipulation of a single piece of data within a larger data structure. Lenses are usually used for updating or reading a specific part within a data structure, whereas optics can be used for more complex data transformations and manipulations. And optics is a library, and lens is also a library. Both libraries provide the functionality to define and use optics. All the lenses, prisms, traversals, and others. Combinators for working with them, and some other capabilities. They are roughly comparable in functionality, but differ in encoding, which we'll cover later what it means. Note that examples in this section rely on the lens library. We are going to review 4 major optics: lens, prism, ISO, and traversal. Lens. It deconstructs product types, such as records and tuples. It's used for getting, setting, or modifying a value when you know that it exists within a structure. A lens must never fail to focus on the value. If you take a simple type, lens SA, it means that some structure S contains a single value of type A. Imagine you have an order data type that has a sneakers field. We can make a lens to access the size of the sneaker in the order, and here sneakers order is a whole, shoe size is a focus, and we can use optics composition, aka dot, to create an order size lens. We can use this lens to get and update the shoe size. View order size current order is a function to get the size of the shoe from the order, and set order size, shoe size 11 current order to update the size of the shoe in the order. Prism. It focuses on at most one value. It deconstructs some types such as either or maybe, and used for accessing data that may or may not be there, but also focusing on one case of a sum type. Simple type prism SA means that type S contains 0 or 1 value of A. Let's see how we can use prism to work with sum types. Imagine we have some data type and a prism. We have a data type sport shoe, and one of its constructor is tennis shoes, which takes a core type parameter. And the prism core type goes from the sport shoes into the core type. We can use a prism to get core type style out of the tennis shoes. The preview function returns the focus of the prism if it's part of the structure, and it returns nothing otherwise, meaning that the prism does not match the structure. So in the case of tennis shoes, it returns just court type, carpet court, and in the case of running shoes, it returns nothing. If we don't need an actual value, we can just check the structure with prism and the function has, which is true for tennis shoes and false for the sneakers, for the running shoes. We can also try updating the styles. If there is nothing to update, in the case of other shoe types, the operation doesn't do anything. And at last, but not least, we can use Prism to embed values into a data type. We can easily create a tennis shoe value or even wrap it in the just right away. Let's see how we can use Prism to work with data that may or may not be there. Imagine we have to shuffle a couple of JSONs. We can use Prism to extract the value of JSON fields that may or may not be there. For example, we can use string and int prisms to try and extract a string or int. In the first example, we extract the field order ID as a string, and then we try to extract the age of the customer from the first order, but the field is missing and returns nothing. But if we try the same optic operation on the second order, it succeeds and returns just 21. Note that we'll cover using optics with JSON at the end of the course. Here's a few common prisms that you can bump into in the wild. Standard prisms for right, left, nothing, and just. Prisms from data ISON lens for working with JSON. Or prism from control exception lens for working with exceptions. ISO, also known as isomorphism, is the most constrained optic. It's used to transform back and forth between two types, but without losing any information. If you have not encountered the term before, it's usually used as a synonym for equivalent. To learn more about this terminology, check out the blog post "What does isomorphism mean?" which we link in the course notes. Simple type ISO SA means we have pretty much a pair of functions from S to A and from A to S. And the two types represent the same information. In practice, ISOs are most commonly used with new types. For example, if we have Sleeper's new type, we can use an ISO to modify the underlying text. It doesn't matter where the ISO comes for now, but we can use it with an over function to lowercase the underlying name. Without the unsleepers ISO, we would need to wrap and unwrap the types ourselves or use some new type library. Let's look at another example. Imagine that we are working on a shoe service and we have a mix of services that work with different size charts. We have a type for European sizes and a type for American sizes. We don't have to deal with the size conversions math by hand. We can use an ISO. We can create it using two functions, from European sizes to American sizes, and from American to European. And if some library exposes a function that only works with US sizes, for example, go one size down, we can easily use it with European sizes, thanks to an ISO and an over function. ISO does all the conversion for us. Traversal. It focuses on 0, 1, or multiple values in a structure or a collection. It's used for applying a function to every focus, like map or traverse functions, and it's used for combining every focus into one value, like fold, for example. Simple type traversal SA means that type S contains 0, 1, or multiple values of A. In some sense, traversal optics is a generalization of traverse from data traversable, because it can be used to perform effectful and pure updates. Moreover, the lens library provides a traversal for any type that implements traversable. And if it feels like there are too many traverse words in the previous paragraph, don't worry, I think the example should make it more clear. We can get the first target of traversal we can modify all targets of traversal or collect and gather all the targets into the list. Spoiler alert, we can compose optics to dive even deeper into the nested structures, which works not only for nested lists, but also for different collections. For example, maybe string. Oh, in the next section, we're going to talk about dealing with nested data, and here's a quick preview. Note that we omit the definition of types and cover them in detail in that section. We can use traversal to update existing stocks. We're going to digest the snippet later, so don't worry. For now, note that the traversal allows us to update all the available stocks across all the shoes, all the inventories, and all the warehouses, which returns the updated response. It has 3 Chuck Taylors instead of 4. Optics are most useful with nested data structures. For example, we can read it from right to left. The focus is on all the elements which are within the warehouse field of a record, which is within the just part of maybe. 80% of what you need to know about optics composition is this. Composing 2 optics of the same type gives you the same optic, but composing 2 different optics will probably give you a traverse or a fold. This is meant to be encouraging and simple, and if you don't like oversimplifications, there are multiple precise cheat sheets on the internet that you can find by Googling it. Let's look at a couple of examples. When you compose 2 optics of the same type, for example prism, you get the same optic. When you compose a lens and a traversal, you get a traversal. We can push it even further with more traversals. Let's do a quick recap. Lens. The type S contains a value of type A, used for product types, such as records or tuples. Prism, the type S contains 0 or 1 value of type A and used for some types, for example maybe or either. ISO, the types S and A are the same or interchangeable and used for interchangeable things, like new types. And traversal, the type S contains 0, 1 or multiple values of type A, which is used for collections and traversable things, such as lists or arrays or maps. If you want to use optics, here's 90% of what you need. How to create lenses and traversals with make lenses, make fields, lens and traverse. How to compose lenses with a dot or composition operator. And how to use a couple of view operators. View, set, overview, preview, and to list off. The most common approaches to using optics are: do not use optics at all, use optics to work with simple records, use generic lenses to work with simple and nested records, use optics with specific data and libraries such as LensISON or Amazonka, use optics here and there for complex or nested data structures, or using optics everywhere. We're not gonna cover the extremes, not using optics at all or using optics for everything. But we'll cover all the other ways, which ones are good, which ones are ugly, and why it's a bad idea to use a full-blown optic library to update a couple of records. And thank you for watching. If you enjoyed this lesson, make sure to check out the rest of the course on Sirocco.io.